Okay, so when we're dealing with reference frames, there's a default. If something says something's going in the positive direction sideways, we always say to the right. If something is traveling vertically, we say up is positive. That's the default. If no one says anything, that's what we're going to assume. Now, if you want to make things easy and things are traveling in the negative direction, then we would go ahead and just say that negative is positive. That's okay. I use that if you're only going in one direction. Just have the origin at its location, and it's going in the direction the object is moving. If the object was traveling only to the right, then we would have to the right be positive. If the object was traveling only up, we'd have up be positive. This is the initial velocity, so if the initial velocity is still always going to be going up. And let's say we drop something. Then have down be positive. Why not? Now, if an object turns around, if you assume an object may turn around, typically people use the default. Okay, so I start out with an object and it's going to go this direction, and maybe it slows down and then it goes back that direction. I'm going to use a default. But even if it's going this way originally, going backwards, and then turns around and speeds up, for me, most of the time I'm going to go ahead and say my oops, I don't want to put it there. It's too confusing if you put the actual reference frame on the object with a 1D. So I'm going to say to the right is positive. I typically will have my initial position still here. So when I go d equals d naught plus initial velocity plus 1/2 at squared. My initial position, whatever you want these to be, these could be x positions, these could be y positions, these can even be like arc length later on. They could even be radius, and the radius is increasing. It does not make any difference. So the initial is nice to have as 0. It just makes things life easier. However, if for some reason you want to break things up and have the green as your system, you can go ahead and put a reference frame where green is, that's the positive direction, is starts over here, because that's where you're starting your system. So really, in this case, if you're only looking at this piece, it's actually similar to a one direction scenario. So you can break up a system into pieces. So that's that one. And ramps. Let's go and look at ramps. If we're going to look at ramps, we can have a ramp that goes like this. Now, if a ramp is going to go down a ramp, right? If you know it's going to go down, use positive to be down. Okay, and I even use up, perpendicular to the ramp as positive as well. Okay, so all the black lines, if you haven't figured them out yet, those are the reference frames. Now, if an object is going to go up and down a ramp, then you're not sure. You have an object and you're shooting it up a ramp. I would typically, if I think it's going to come back down again, I'd go like this. Positive is down the ramp. So I'd start out with a negative velocity here. Okay. and there'd be a positive acceleration to it. But you get to pick the reference frame. It's all up to you. It's just conventions, and this is the default. One more piece, if we are looking at 2 dimensions and we have an object on a cliff, and we started out here, I'm going to go ahead and pick the initial position right here as positive, and positives here, because I know that it's always going to be going to the right and always going down. So my horizontal is always positive and my vertical is always positive. If I launch something off the ground, I know it's going to go up, and then it's going to come back down again. You can guess that I'm going to go up is positive, going back to my conventions, and to the right is positive. That's the default. Makes life easier. Thanks for listening.